It begins with a countdown. At Vandenberg Air Force Base, California, a lone Atlas V rocket stands beneath a cloudless February sky. The air trembles with tension. Engineers murmur into headsets, their voices blending with the steady rhythm of numbers ticking down through the speakers. 10, 9, 8. The rocket is more than metal and circuitry. It carries the weight of 4 decades of science and an unbroken record of our planet's memory. Its mission is called Landsat 8, the latest in a long line of Earth-observing satellites that have quietly watched over our world from orbit. It isn't just another spacecraft. It's a vessel of continuity, a promise that the record of Earth's surface, stretching back to the early 1970s, will not be broken. When the engines ignite, a column of fire lifts the craft toward the edge of the atmosphere. To most watching, it's a triumph of engineering. But to those who have worked on the Landsat program for years, it's something more personal, a preservation of legacy. For if the launch fails, an entire archive of knowledge, decades of images documenting forests, rivers, cities, and deserts, could end abruptly. If it succeeds, the story of our planet will keep unfolding. We often imagine space exploration as an outward journey, a quest for distant worlds, for the red dust of Mars or the icy plains of Europa. Yet Landsat's mission turns our gaze homeward. It studies not alien terrain, but the only planet known to harbor life, Earth. Through its eyes, we see our world as never before. Its beauty, its resilience, and its fragility. For half a century, the Landsat program has given scientists a continuous portrait of change. It has watched forests disappear and rivers reroute. It has traced the growth of cities, the retreat of glaciers, and the scars of drought and fire. Its imagery tells stories that no human witness could ever fully see from the ground. To lose that vision would be to lose our most complete mirror. But this program was never born from environmental concern. Its origins lie in the Cold War, when the race for space was driven by rivalry, not stewardship. From the hands of astronauts with handheld cameras to satellites equipped with sensors that could see beyond human sight, the evolution of Earth observation has mirrored our own awakening to the planet's vulnerability. Now, as climate change accelerates and ecosystems reach their breaking points, Landsat's role has shifted from exploration to survival. Each image it captures is not just a snapshot of geography. It's evidence, a data point in the unfolding story of a species transforming its own home. The launch of Landsat 8 is therefore not merely a beginning. It's an act of preservation. It ensures that the chain remains unbroken, that humanity continues to hold a clear, unbiased record of its actions, its progress, and its mistakes. In the vastness of space, where planets come and go without witnesses, one small satellite circles a fragile blue sphere, collecting light reflected from oceans, deserts, and forests. Through that light, we learn who we are and what we've done. This is the story of how we learned to see the Earth, from the first flickering photographs taken by astronauts to the modern eyes that orbit above us today. It's a story about technology, discovery, and the quiet revolution that changed not just how we look at our planet, but how we understand it. It begins not with the question, can we reach the stars? But with something far more urgent. Can we truly see our own world before it's too late? Part 1. The first glimpse from orbit. It's 1962. The United States is locked in a race for the heavens. The Soviet Union has already sent men into orbit, and the pressure on NASA is immense. Every launch, every test flight, carries the weight of national pride. Yet amid the feverish drive to reach the moon, a few astronauts begin to notice something else. Something beyond their mission objectives. For the first time in history, human eyes are looking down at Earth from space. From the narrow windows of their Mercury capsules, the astronauts describe what they see as breathtaking. Vast oceans of blue wrapped in swirling white clouds, the dark sweep of continents below. They are alone, surrounded by the void, yet what grips them most is the living planet turning silently beneath their feet. These early spacefarers carry small handheld cameras, simple by today's standards, but powerful enough to capture the world in a way no one has seen before. The photographs they bring back are mesmerizing. Mountains fold like rumpled fabric. Rivers snake across deserts that shimmer in sunlight. Even in black and white, the images reveal the raw geometry of Earth's landscapes. Until this moment, scientists have relied on aerial photographs taken from planes to map terrain. But here, orbiting hundreds of kilometers above the surface, astronauts are capturing images that stretch across entire continents. The potential is enormous. What began as a military and political endeavor is suddenly opening a new scientific frontier. By the time the Mercury program gives way to Gemini, the technology improves. The flights last longer, days instead of hours, and the astronauts are trained to photograph specific features: coastlines, mountain ranges, and areas of geological interest. Between 1965 and 1966, they capture over 1,000 images. These are not just pretty pictures. They are the first scientific observations of our planet from space. When researchers on the ground analyze the photographs, they notice details they could never have seen before. Patterns in vegetation, shifts in river courses, scars from ancient glaciers. The Earth, it seems, is not static. It's alive, changing, evolving. Among those captivated by these discoveries is William Pecora, the director of the U.S. Geological Survey. Pecora is a geologist, not an astronaut, but he sees something that others don't: a new way to study the planet itself. To him, space photography isn't just a novelty. It's the beginning of a revolution in Earth science. He envisions satellites dedicated not to warfare or weather, but to the systematic observation of the Earth's surface. They would capture images in multiple wavelengths of light, beyond what human eyes can see. With this data, scientists could study forests, farmland, minerals, and water, all on a global scale. It's a bold idea, and in the mid-1960s, it's also a controversial one. NASA is consumed with the Apollo program, racing to land astronauts on the moon before the decade ends. Resources are scarce, and government officials question why they should fund a project that looks back toward Earth instead of outward to space. There are also political and military concerns. A civilian satellite capable of photographing other nations' territories could ignite diplomatic tensions. Yet Pecora persists. In 1966, he formally proposes the Earth Resources Technology Satellite, ERTS for short. He argues that understanding our planet's resources is as vital to humanity as exploring other worlds. The Department of the Interior supports him. NASA, cautious but intrigued, agrees to build the spacecraft. The first Earth-observing satellite is born. In July 1972, after years of debate and development, ERTS-1 is launched from Vandenberg Air Force Base. It enters a near-polar orbit, circling the planet every 103 minutes. For the first time, humanity has an automated eye in the sky, an instrument designed not to spy but to study. Tragically, William Pecora doesn't live to see it. He dies just days before the launch at the age of 59. But his vision endures. When the data begins to stream in, scientists are stunned. The images reveal forests, deserts, and coastlines in astonishing detail. Rivers gleam like threads of silver. Patterns of agriculture appear as intricate mosaics. Entire ecosystems are visible from a single frame. It's a new kind of map, a living map. Soon, ERTS-1 is renamed Landsat-1, and the program expands. Landsat-2 follows in 1975, then Landsat-3, and so on. Together, they build an unbroken chain of data, a continuous portrait of Earth's surface that will one day stretch across half a century. At first, few outside the scientific community notice. The images are technical, not glamorous. But gradually, their importance becomes clear. Landsat satellites are not merely showing us where things are, they're showing us how they change. For the first time in human history, we can measure deforestation, track the growth of cities, and monitor the health of crops from orbit. The world, once mysterious and unmapped, is now under constant observation. And with each new image, a realization grows stronger. The planet we are watching is not infinite. This is how the age of Earth observation truly begins. not with a telescope aimed at the stars, but with a lens turned homeward. Part 2, the birth of a new science. By the mid-1970s, the world is changing faster than ever before. New cities rise from desert plains. Vast forests are cleared to make way for fields and highways. Rivers are dammed, oceans are trawled, glaciers shrink. Yet for most people on the ground, these transformations unfold too slowly, too subtly to notice. From orbit, the view is very different. The Landsat satellites begin sending back images that astonish scientists. Each orbit paints another stripe across the globe, capturing forests in South America, ice sheets in Antarctica, the volcanic ridges of the Pacific, and the deserts of Africa. With every pass, they build a living mosaic of the planet, one that reveals not just geography but movement and change. The technology behind it is quietly revolutionary. Unlike ordinary cameras, Landsat sensors can detect multiple wavelengths of light, including those beyond the range of human vision, infrared, near-infrared, and thermal bands that reveal hidden details about soil, vegetation, and water. By assigning colors to these invisible wavelengths, researchers can see things that would otherwise remain unseen. A healthy forest glows red under infrared imaging, while dry or diseased vegetation fades to dull brown. Rivers that appear calm and opaque in normal photographs become vivid channels of energy. The ocean's surface patterns betray currents, sediment plumes, even algal blooms. To the scientists at NASA and the U.S. Geological Survey, it's as if the planet has learned to speak a new language, one of color, contrast, and spectral light. This new way of seeing gives rise to a new discipline, remote sensing. At first, the field feels like science fiction. Researchers sit before banks of computers, decoding patterns of light and shadow from hundreds of kilometers above the Earth. But soon the applications multiply. Agronomists use Landsat images to forecast harvest yields and detect droughts before they strike. Hydrologists map watersheds and monitor the expansion of irrigation networks. Geologists identify mineral deposits, and urban planners chart the unstoppable growth of cities. Even the smallest details matter. In 1976, a speck of land less than 50 meters across appears off the coast of Labrador. It had gone unnoticed for centuries, too small to be charted by sailors or aircraft. But Landsat spots it. The discovery is confirmed, and the nameless island is added to the maps. Its name? Landsat Island, a quiet tribute to the satellite that found it. Yet the true power of Landsat imagery lies not in mapping the unknown, but in revealing how the known world changes over time. When researchers compare images taken years apart, they begin to see a pattern, a global heartbeat. Forests shrink, rivers shift their courses, glaciers retreat, cities sprawl outward like living organisms. The Earth, once thought to be stable and enduring, is now seen as dynamic, fragile, and deeply interconnected. In this way, Landsat doesn't just record data, it reshapes how humanity perceives the planet. Governments and universities soon build archives of satellite imagery, preserving each frame like a page in an enormous visual diary. These records become invaluable for environmental monitoring, resource management, and disaster response. The satellites may be distant, but their influence reaches deep into daily life, forecasting floods, managing fisheries, and even planning humanitarian aid. Still, not everyone is pleased. Some nations object to the idea of being photographed from space. The ability to see across borders and continents raises questions about privacy, sovereignty, and control. Could satellite data be used for espionage, for manipulation of markets or resources, for military advantage? To ease such fears, the U.S. emphasizes that Landsat is a civilian program, one dedicated to science and transparency. Data from the satellites is made publicly available, allowing scientists around the world to access and analyze it. Slowly, suspicion turns into cooperation. By the 1980s, space agencies from Europe, Japan, and Canada begin developing their own Earth-observing missions. What started as an American experiment becomes a global effort to monitor the planet's health. But the success of the Landsat program is fragile. Each satellite has a finite lifespan, and the cost of building new ones is high. Political priorities shift, funding waxes and wanes. In 1993, the launch of Landsat 6 ends in failure, its rocket lost before reaching orbit. For a moment, the continuity of the world's longest-running Earth observation record hangs by a thread. The data chain must not be broken. Engineers and scientists rally to save the program. In 1999, Landsat 7 is launched successfully, restoring the mission's momentum. For the next decade, it captures millions of images. But even it suffers damage. A critical component malfunctions, creating stripes of missing data across its photographs. Once again, the program teeters on the edge. And yet, against all odds, Landsat 5, launched back in 1984, continues to function year after year, defying its expected lifespan. It becomes the longest operating Earth observation satellite in history, transmitting data for nearly 3 decades. When it finally falls silent in 2013, it leaves behind a priceless visual record of the planet's transformation. Through every setback and success, the principle remains unchanged: to watch the Earth, to understand it, and to remember. By the dawn of the 21st century, remote sensing has evolved from a niche scientific pursuit into a cornerstone of environmental awareness. The satellites orbit quietly, their instruments sweeping across continents and oceans, capturing not moments, but centuries in motion. And with Landsat 8 preparing for launch, a new chapter is about to begin. For the planet it observes is no longer the same. The forests are thinner, the ice is retreating, the atmosphere itself bears the mark of human hands. Landsat's mission, to see the Earth clearly, has never been more urgent. Part 3. The planet in motion every 16 days. The Earth turns beneath the steady gaze of Landsat's lenses. From an altitude of more than 700 kilometers, each satellite completes its orbit with mathematical precision, tracing a continuous path from pole to pole. What it sees is not static. It's a living, restless world in constant motion. To the human eye, these changes are invisible. A mountain range doesn't seem to move. A river valley looks the same year after year. Forests, fields, and cities all appear solid and permanent. But Landsat's unblinking vision sees what our eyes cannot: the slow breathing of the planet. Over decades, that breathing has grown faster. When scientists began comparing Landsat images taken years apart, the results were startling. In northern Canada, glaciers that once sprawled like frozen rivers have begun to retreat, their icy edges melting into pools of cobalt blue. In Brazil, the dark green expanse of the Amazon is scarred by widening roads and patchwork clearings, each one the mark of deforestation. And across the globe, rivers once steady and predictable have started to shift, forming new channels as rainfall patterns change. The Earth's surface, land, water, ice, and vegetation, is rearranging itself before our eyes. But nowhere is this transformation more haunting than in Central Asia. There, the Aral Sea, once the 4th largest lake in the world, has all but vanished. For thousands of years, it nourished civilizations, supported fisheries, and cooled the surrounding desert air. Then, in the mid-20th century, its lifeblood was diverted. Soviet irrigation projects drained the rivers that fed it, turning vast tracts of land into cotton farms. At first, the impact seemed manageable. Then, Landsat began taking pictures. From the early 1970s to the 2000s, a sequence of satellite images captured the Aral Sea's slow death. Each frame showed the waterline receding farther, the once deep blue shrinking into pale salt flats. By the time Landsat 7 and 8 recorded it, the sea had split into fragments, lifeless, toxic, and dry. A fishing industry collapsed. Communities vanished. Dust storms carried salt and pesticides for hundreds of kilometers. What had taken nature millennia to create had been undone in less than a generation. Landsat didn't cause this tragedy, but it revealed it with undeniable clarity. The images became more than scientific data. They became evidence, powerful visual proof of how human ambition can alter entire ecosystems. Scientists, journalists, and policymakers used them to expose what was once hidden. In this sense, Landsat's mission expanded far beyond science. It became a moral mirror for the planet. That same mirror has reflected beauty as well as loss. In Oman, Landsat captured a breathtaking image of the Dhofar Mountains, emerald green against the ochre desert, a narrow strip of life sustained by the summer monsoon. In Alaska, it revealed the shimmering blues of the Columbia Glacier as it fragmented into the sea. Over the Mississippi Delta, the satellites recorded swirling ribbons of sediment, delicate as watercolor brushstrokes, marking where the Great River meets the Gulf of Mexico. Each image tells a story. Together, they form an atlas of motion, the pulse of the Earth rendered in color and light. Yet the true power of Landsat lies not just in individual snapshots, but in their accumulation. Decades of continuous observation have created a dataset unlike any other, a digital memory of the planet. With it, scientists can trace long-term trends, not just where change happens, but how fast and why. They can measure the advance of deserts, the spread of wildfires, the rebirth of wetlands, the impact of urban sprawl. They can calculate the health of crops, predict water shortages, and assess the aftermath of hurricanes. In this way, Landsat has become both a historian and a prophet, chronicling the past while forecasting the future. But as the satellites continued to reveal more, the images began to raise troubling questions. If this is how quickly the Earth is changing now, what will the next 50 years look like? By the late 20th century, scientists could already see the signs. The ice sheets of Greenland and Antarctica were thinning. Coral reefs were bleaching. The great forests of the tropics, once called the lungs of the Earth, were gasping under the weight of logging, fire, and drought. Each new Landsat image was another line in a growing warning. And still, the satellites kept watching, faithfully, silently, relentlessly. From the orbiting vantage point of a machine, humanity's footprint is unmissable. Cities expand outward in luminous webs, their lights glowing brighter each year. Highways carve through wilderness like veins of silver. Reservoirs swell behind dams. Mines scar the Earth in spirals and pits. The data does not lie. The planet is in motion, but it is a motion of our own making. Yet within that movement, there is still resilience. The same technology that exposes our impact also reveals the Earth's capacity to recover. Forests regrowing on abandoned farmland, wetlands reclaiming forgotten deltas, rivers cutting new courses after centuries of confinement. Landsat doesn't judge. It only shows us the truth. And in that truth lies both the danger and the hope of our time. For as long as its cameras remain open, we will keep learning what kind of world we are shaping, and whether it's one we can still call home. Part 4, The Turning Point. When the data spoke back by the dawn of the 21st century, humanity had grown accustomed to seeing Earth from above. Satellite imagery had become routine, used by scientists, journalists, governments, and even the public. But somewhere along the way, the quiet stream of data from orbit began to take on a new, urgent meaning. Landsat was no longer just a scientific tool. It had become the planet's memory, and that memory was starting to sound an alarm. The early 2000s marked a turning point. For decades, the Landsat program had been run primarily by NASA and the U.S. Geological Survey, its images stored in massive archives that only specialists could access. But in 2008, something remarkable happened. The U.S. government made the decision to release the entire Landsat database to the public for free. In an instant, more than 30 years of Earth's history became open to everyone. What followed was a revolution. Scientists began combining Landsat data with new computational tools, machine learning, digital mapping, and cloud processing. Suddenly, it was possible to see the planet's transformations in unprecedented detail and speed. Forest loss could be mapped in near real time. Glacial retreat could be measured down to the meter. Urban growth could be visualized like a time-lapse of civilization itself. For the first time, the Earth could speak back to us in data. One of the earliest and most dramatic revelations came from South America. Researchers studying the Amazon basin used Landsat imagery to track the spread of deforestation. The numbers were staggering. In the Brazilian state of Rondônia, satellite records showed how a once continuous rainforest had been carved into a pattern resembling fish bones. Roads slicing through the jungle, followed by systematic clearing of the land. By overlaying decades of imagery, scientists could calculate exactly how much forest had disappeared. Millions of hectares, transformed into farmland and pasture. Roughly 16% of the Amazon rainforest, an ecosystem that had taken millions of years to evolve, was gone in less than 4 decades. Elsewhere, the data revealed stories of human adaptation and ambition. In China, Landsat documented the creation of the Three Gorges Dam, one of the largest engineering projects in history. Over a span of years, entire valleys were submerged, forming a reservoir that displaced more than 1 million people. In the American Southwest, the city of Las Vegas exploded outward across the Nevada desert, its bright sprawl straining the region's fragile water supply. And far to the north, Landsat sensors watched the Columbia Glacier in Alaska retreat at an accelerating pace. Its shimmering ice breaking apart, flowing faster, crumbling into the sea. It was one of the most vivid demonstrations of climate change ever captured from space. Each of these stories was told through pixels, tiny squares of color, each representing 30 meters of the Earth's surface. But together, they revealed a truth far larger than any one photograph. Humanity had become a geologic force. For the scientists working with the data, this realization was profound. It was no longer possible to separate nature from civilization, or to pretend that human activity existed outside the planet's natural cycles. The boundary between the built world and the natural world had dissolved. And in the middle of it all, the Landsat satellites kept watching, silent witnesses to an age of transformation. When Landsat 5 finally ceased operations in early 2013 after 28 years in orbit, its passing felt almost human. Engineers who had worked with the satellite for decades spoke of it with affection, as if saying goodbye to a colleague. It had endured countless micrometeoroid strikes, radiation exposure, and technical malfunctions, yet it had persisted, outliving its expected lifespan 5 times over. Its successor, Landsat 8, was waiting on the launch pad, but the stakes had never been higher. Landsat 7 was still functioning, though its imaging sensor was damaged, producing incomplete pictures. If the new satellite failed, the world's longest continuous record of Earth observation would be broken, 40 years of data, lost in an instant. On February 11, 2013, as the Atlas V rocket roared into the California sky, every engineer at Mission Control held their breath. Minutes later, the confirmation came through. Landsat 8 has achieved orbit. All systems nominal. Applause erupted, and relief washed through the control room. The chain had been preserved. When the first images arrived, scientists were stunned. The colors were sharper, the resolution finer, the coverage broader. Landsat 8 could see not just invisible light, but across a spectrum of wavelengths: infrared, near-infrared, shortwave infrared, and thermal. With these, researchers could track everything from drought stress in crops to the temperature of ocean currents. It was as though the planet had been given a new set of eyes. Within weeks, the satellite was returning more than 400 images per day, feeding an ever-growing archive of planetary memory. The images were spectacular, but they were also sobering. The more clearly we saw the Earth, the more fragile it appeared. And yet, amid the warnings written in light and shadow, there was something else, an awakening. For the first time, people everywhere could witness the same truth the scientists saw. The planet was alive, changing, and watching it had become a shared human endeavor. This was no longer just the story of a satellite. It was the story of humanity learning to see itself from above, and perhaps to understand the consequences of its own power. But the Landsat program's journey was far from over. Beyond the silent orbits and streams of data, a deeper question lingered. What happens when our own reflection becomes too clear to ignore? Part 5, Remote Sensing. The science of seeing from afar. For most of human history, observation meant being present. To study something, you had to be there. Scientists trekked into forests, climbed mountains, and sailed across oceans to collect samples by hand. But with the advent of remote sensing, that limitation vanished. Landsat turned the entire planet into a laboratory, one that could be observed, measured, and analyzed from hundreds of kilometers above. It was the first great technological leap that allowed humanity to see the Earth without ever touching it. At its heart, remote sensing is built on a simple truth. Everything on Earth interacts with light in a unique way. When sunlight hits a forest, a glacier, a city, or the ocean, part of it is absorbed and part is reflected. Different materials, rock, vegetation, water, concrete, each reflect light in distinctive spectral signatures, like fingerprints written in color. Landsat's job is to read those fingerprints. Every image it captures is a coded message from the planet's surface, recorded in wavelengths invisible to the human eye. Scientists use algorithms to translate these signals into maps, graphs, and images, representations that turn complex radiation patterns into something our minds can understand. But Landsat doesn't just take pictures. It measures relationships. From orbit, it can tell how healthy a forest is by analyzing the intensity of reflected near-infrared light. It can identify regions of drought long before plants begin to wither, because stressed vegetation reflects light differently. It can measure the heat radiating from urban centers, revealing the growing footprint of the urban heat island effect. This ability to detect the invisible has transformed almost every scientific field. In agriculture, remote sensing allows farmers to manage crops with surgical precision. Instead of watering entire fields blindly, they can identify exactly which areas need irrigation, reducing waste and improving yields. In climatology, Landsat's long record provides the baseline data needed to model global warming, compare historical conditions, and predict future trends. Even archaeology has been changed by it. Hidden beneath the sands of Egypt and the jungles of Central America, ancient cities once lost to time have been rediscovered through subtle variations in soil color and texture, details that only satellites could detect. But for all its sophistication, the principle behind remote sensing remains elegantly simple. By studying how light interacts with matter, we can infer what's happening on the ground, even when we can't see it directly. That simplicity makes the system resilient. Landsat satellites are built to be efficient, not extravagant. They carry sensors designed to balance coverage with clarity, imaging swaths of land 185 kilometers wide, at a resolution fine enough to identify major features, but broad enough to capture continental-scale trends. Each satellite follows a sun-synchronous orbit, meaning it passes over any given point on Earth at roughly the same local time every 16 days, usually around 10 a.m. This consistency ensures that lighting conditions are nearly identical from one image to the next, allowing scientists to compare changes over time without the distortions of shifting shadows or angles. It is, in essence, a time machine of light. Over the decades, the power of remote sensing has expanded beyond Landsat. Dozens of satellites now circle the Earth, from NASA's Terra and Aqua missions to the European Space Agency's Copernicus program and Canada's RadarSat fleet. Together, they form a global network of eyes, each tuned to different frequencies, each watching for signs of change. Some observe the oceans, measuring surface temperature, chlorophyll content, and currents. Others track the movement of carbon in the atmosphere, the thickness of ice sheets, or the spread of wildfires. The result is an unbroken symphony of observation, a planetary surveillance system not for control, but for understanding. And yet, amid all the data, one truth remains constant. Landsat's record is the foundation. Its archive, continuous, consistent, and calibrated, is the benchmark against which all others are measured. Without it, newer satellites would have no reference, no baseline for comparison. The continuity of its observations is what transforms decades of images into evidence, and evidence into knowledge. But remote sensing has also revealed uncomfortable patterns, insights that humanity can no longer ignore. When data from multiple satellites is combined, the results are sobering. The planet's ice sheets are melting faster than expected. Global sea levels are rising at an accelerating rate. The extent of Arctic summer sea ice, once stable for millennia, has declined by nearly half since the 1980s. Forests that once absorbed carbon are now releasing it, as fires and logging outpace regrowth. In the vast tapestry of light and color that Landsat records, there are more darkening patches than brightening ones. Still, the value of remote sensing lies not just in documenting decline, but in providing the tools for resilience. When floods strike, Landsat data helps emergency teams locate stranded communities. When drought looms, it helps governments plan for water shortages. When wildfires rage, its thermal sensors track their spread in near real time, helping firefighters predict where the flames will move next. It has become the planet's nervous system, alerting us to pain, signaling where attention is needed, and like a nervous system, its signals are only useful if we choose to listen. As Landsat 8 continues to orbit and Landsat 9 prepares to join it, humanity faces a stark choice: to use this power of vision to preserve what remains, or to watch, in exquisite clarity, as the world changes beyond recognition. Because to see from afar is not the same as to understand, and understanding, in the end, is the only thing that can save us. Part 6, The Web of Observation. A planet under watch by the mid-2010s, Earth had become the most observed object in the known universe. Every hour, hundreds of satellites sweep across its face. Some public, some private, some military, others purely scientific. Together they form a delicate, silent lattice of orbiting machines. A web of observation suspended over a living world. At the center of that web is Landsat. It doesn't look impressive beside newer, high-resolution imagers capable of zooming in on cars, buildings, even individual trees. Landsat's power lies not in its sharpness, but in its continuity. It sees the whole Earth again and again in exactly the same way. Its purpose isn't surveillance, it's memory. Every 16 days, the satellites return to their assigned tracks. From pole to pole, they record the pulse of the planet, the breathing of the Amazon, the ebb and flow of snowpack, the steady spread of desert dunes. Each orbit adds another brushstroke to a portrait that began half a century ago. Yet Landsat no longer watches alone. In orbit nearby are NASA's Terra and Aqua satellites, armed with instruments that measure heat, radiation, and atmospheric chemistry. Europe's Sentinel fleet scans the land and sea with radar and multispectral sensors. Canada's RadarSat peers through clouds and darkness, mapping floods and ice with microwave precision. Japan, India, and China contribute their own missions. Dozens of smaller CubeSats, operated by universities and startups, fill in the gaps, creating near-constant global coverage. To the untrained eye, this network might seem redundant. But in science, redundancy means reliability. Different satellites observe the same scene with different instruments, confirming each other's readings and revealing details invisible to any single sensor. One sees heat, another moisture, another texture, another motion. When combined, their data forms a multidimensional map of the planet's condition. It's a kind of planetary symphony, each satellite an instrument, each frequency a note, together playing the rhythm of the Earth. Through this collaboration, humanity has learned to measure the planet's heartbeat with astonishing precision. The results are both awe-inspiring and deeply unsettling. We now know, for example, that the Greenland ice sheet is losing an average of 270 billion tons of ice every year, enough to raise global sea levels by nearly a millimeter annually. We can track the exact pace of desertification across the Sahel, or watch new islands rise from volcanic eruptions in the Pacific. We can even detect subtle shifts in gravity caused by the depletion of groundwater beneath major agricultural regions. In short, we've given the planet a mirror and it reflects everything. But there's a paradox in this new clarity. The more we see, the more complex the story becomes. Data floods in at a rate humanity can barely comprehend. Every 24 hours, the world's Earth observation satellites produce terabytes of raw information, images, temperature readings, atmospheric samples, spectral signatures. Turning that deluge into understanding requires armies of scientists, supercomputers, and algorithms capable of finding patterns amid chaos. And sometimes, those patterns reveal truths we weren't ready to face. For decades, environmental change had been measured in local terms. Deforestation here, drought there. Now, the satellites show that these events are interconnected. When ice melts in the Arctic, rainfall patterns shift in Africa. When forests burn in the Amazon, carbon levels rise across the globe. What happens in one hemisphere echoes in the other. In this way, the web of observation has exposed something profound. Earth's systems are not separate. They're a single, living organism, bound by flows of energy, air, and water. And humanity is both part of that organism and its greatest source of disturbance. Yet there is beauty in the watching. At night, when the Earth turns its dark side toward space, the network sensors capture a luminous world stitched together by light, cities glowing like constellations, fishing fleets tracing glowing arcs across the seas, highways threading through continents like veins of fire. It's a haunting reflection of our civilization, radiant and fragile against the blackness of space. To some, these images are proof of progress. To others, a warning flare. Either way, Landsat's mission endures as the quiet constant amid this storm of observation. Its long, steady record anchors the rest. Without it, the newer satellites would drift through data without context, their discoveries untethered from history. The planet is now under near-permanent watch, but observation alone isn't salvation. The data reveals what is not what ought to be. The satellites can show us the fever, but they cannot lower it. That task still belongs to us. As the 21st century advances, the web of observation tightens, becoming both a guardian and a reminder. Every pixel is a message, a record of what we've done, what we're losing, and what we might still save. High above, Landsat continues its patient vigil, circling the globe every 99 minutes, gathering the faint reflections of sunlight off ocean, ice, and stone. Below, humanity looks back at the images, our own reflection stitched together from millions of points of light, and realizes that the observer and the observed have become one and the same. Part 7, Climate in Motion. The data of a warming world for centuries, the weather was treated as something beyond comprehension, a force of nature, unpredictable and divine. Farmers relied on instinct and folklore. Sailors trusted the sky. But now, from orbit, the atmosphere is no longer a mystery. It's a system vast, measurable, and changing faster than anyone expected. And the satellites see everything. Landsat's imagery, layered with data from newer missions like NASA's Terra, Aqua, and the European Sentinel fleet, paints a sobering picture. The planet's climate is in motion, and that motion is accelerating. At first glance, a single image might seem ordinary. A coastline, a glacier, a forest canopy. But when those images are stacked across decades, the transformation is undeniable. Glaciers that once filled entire valleys have vanished. Lakes that shimmered in the Sahara are now dust. Whole islands have slipped beneath rising seas. What was once static is now dynamic. What was once predictable is now volatile. The Earth's climate system, a delicate balance of heat, air, and water, is shifting in ways that only long-term observation can reveal. Landsat doesn't measure temperature directly, but it sees its fingerprints everywhere. In the retreat of snow cover, the greening of tundra, the expansion of deserts, the drying of rivers. In the Himalayas, Landsat data shows thousands of glaciers shrinking, some by more than half their volume since the 1980s. These glaciers feed the great rivers of Asia, the Ganges, Indus, Mekong, Yangtze lifelines for nearly 2 billion people. As they recede, the threat isn't just sea level rise, but water scarcity, crop failure, and conflict. Far to the north, in the Arctic, the satellite sensors have recorded an equally dramatic change. Summer sea ice, once a vast mirror reflecting sunlight into space, has been diminishing year after year. The white expanse that once covered millions of square kilometers has thinned and fractured, revealing dark ocean beneath, water that absorbs heat instead of reflecting it. It's a feedback loop the satellites can literally see. As the ice retreats, the planet warms faster, melting even more ice in return. And in Greenland, the data tells a story of acceleration. Between 2002 and 2020, the ice sheet lost over 4 trillion tons of mass. Landsat's imagery shows rivers of meltwater carving deep blue veins across the surface, flowing into the sea like veins of liquid glass. Each summer, the loss grows worse. Yet perhaps the most unsettling revelations come not from the poles, but from the tropics. Landsat's long record has allowed scientists to track deforestation and land degradation with mathematical precision. In the Amazon, more than 700,000 square kilometers of forest, an area twice the size of Germany, has been cleared since the program began. Each patch of missing canopy alters rainfall patterns, releasing massive stores of carbon once locked safely in the soil. The planet's lungs are beginning to wheeze. But amid the data, there are signs of resilience too. Landsat has recorded the regrowth of forests in Costa Rica and Vietnam, where conservation efforts and replanting projects are beginning to heal scars once thought permanent. In parts of Africa, communities have used satellite data to restore water basins and reforest barren land, guided by what the images reveal. This duality, collapse, and recovery defines the era of climate observation. Never before has humanity understood the Earth's systems so completely, and yet, never before has it seen the consequences of its own actions so clearly. Every satellite pass is a mirror held to civilization, reflecting not just our technologies, but our choices. From space, borders vanish. There are no nations, no divisions, only patterns, swirling clouds, flowing rivers, spreading fires. Landsat's data shows wildfires in Australia's outback connecting in seasonal rhythm to droughts in California and floods in South Asia. Each event ripples across the atmosphere, its signature visible in temperature gradients and smoke plumes stretching thousands of kilometers. What emerges is an image of a planet alive but feverish. The scientists who study these images speak of tipping points, thresholds beyond which recovery becomes impossible. They use the data not to predict apocalypse, but to understand proximity, how close we are to irreversible change. And though the numbers are grim, they are not without hope, because the same satellites that chart destruction also guide response. When the Amazon burns, Landsat helps firefighters locate active fronts. When glaciers calve, it helps coastal planners anticipate rising tides. When crops fail, it helps humanitarian organizations identify regions most at risk of famine. In this way, every pixel becomes an act of both witness and warning. But as the data grows clearer, so does the moral weight it carries. For years, the satellites have shown what governments often denied: the measurable, accelerating consequences of human industry. The images are silent, but their testimony is irrefutable. They have become, in a sense, the conscience of the planet. And now, as global temperatures climb and weather grows more violent, the question is no longer what is happening. The satellites have already answered that. The question is, will we act on what we see? Above the swirling clouds, Landsat continues its orbit, patient, tireless, indifferent. It will keep watching whether we change or not. Its cameras will record every flood, every fire, every miracle of renewal. Cannot save us, but it can show us the truth. And sometimes truth is the first step toward redemption. Part 8: Signals in the Noise. When the Earth spoke back at first, it was just data, numbers and spreadsheets, sequences of spectral readings, values fluctuating between wavelengths. To the untrained eye, it looked like random noise. But buried within that noise, patterns began to emerge. Small, consistent, impossible to ignore. The Earth, it seemed, was trying to tell us something. Scientists at NASA's Goddard Space Flight Center and the U.S. Geological Survey had been analyzing Landsat's data archives for decades. But around the early 2020s, machine learning algorithms began finding subtle, correlated signals, shifts in light, color, and temperature that followed no known seasonal or geological pattern. In the forests of the Amazon, pixels that once represented deep green canopy began pulsing faintly in the near-infrared bands, fluctuating in rhythm with distant rainfall hundreds of kilometers away. Across the Arctic, thermal readings rose and fell in a synchronized pattern, matching oceanic currents rather than air temperature. It wasn't random, it was resonance. As the algorithms refined themselves, new connections surfaced. A drought in Africa could be traced through atmospheric moisture patterns all the way to heat anomalies in the Pacific. The planet was revealing its feedback loops in real time, the interconnected web of cause and effect that tied every forest, ocean, and glacier into one breathing organism. For the scientists watching, it felt almost alive. Of course, no one seriously believed the Earth was conscious. But the data painted a picture of startling complexity, a world that behaves less like a static system and more like a dynamic body, self-regulating, self-reacting. When forests fell, rainfall shifted. When oceans warmed, deserts grew. The feedbacks were faster and stronger than the models had predicted. And for the first time, Landsat's decades of imagery provided the timeline to prove it. When the first satellite launched in 1972, humanity still imagined Earth as stable, enduring. But half a century of observation showed otherwise. The planet's rhythms, once thought geological, unfolding over millennia, were now accelerating into decades, even years. Ice that took 1,000 years to form could vanish in a single season. Entire biomes could collapse in one generation. To some researchers, the data resembled a signal from a system under stress, the trembling pulse of a patient approaching fever. In 2021, an interdisciplinary team from MIT and the European Space Agency began cross-referencing Landsat imagery with atmospheric and oceanic data. Their results were unsettling. The Earth's energy balance, the difference between solar energy absorbed and infrared radiation emitted, was no longer stable. The planet was retaining more heat than it released, by a margin growing each year. They called it the planetary energy imbalance, a quiet crisis invisible to the naked eye but crystal clear in satellite data. From orbit, it showed up not as one dramatic event but as a subtle, consistent shift in the tone of the Earth itself. The oceans, once deep blue, began reflecting slightly more infrared light, a sign of warming. Vegetation zones crept northward. Snow melted earlier. The planet's spectral signature, its fingerprint of reflected light, was changing color. And in that color shift, scientists saw a warning. The Earth was no longer the same planet Landsat had first photographed. Yet, even as the data grew alarming, it was also strangely beautiful. The images, when animated across decades, looked like time-lapse paintings. Rivers weaving through continents, coastlines breathing in and out, cities spreading like constellations. From afar, the Earth appeared almost alive in motion, a single vast organism reshaping itself. This realization began to blur the boundaries between science and philosophy. If the planet behaves like a living system, self-regulating, self-healing, and, when pushed too far, self-defending, what does that make humanity? Parasite or caretaker? Catalyst or consequence? Landsat couldn't answer those questions, could only keep showing the evidence one frame at a time. And sometimes, the evidence came in the form of anomalies that even experts struggled to explain. In 2022, a faint thermal pulse was detected deep in the Siberian tundra. A sudden, localized burst of heat that lasted only minutes but spanned several kilometers. It didn't match any wildfire signature or geological event. The same phenomenon appeared again months later in Alaska. Then in the Arctic Ocean, brief, silent flashes of warmth in the frozen wilderness. The anomalies faded as quickly as they came, leaving no visible scars. Yet the sensors recorded them all. Most dismissed the events as instrument noise or as methane releases from thawing permafrost. But others weren't so sure. The patterns were too uniform, the timing too precise. It was as though the planet's systems were convulsing, not randomly, but rhythmically. To some, this was only the natural consequence of imbalance. A planet attempting, in its own way, to restore equilibrium. To others, it was the first sign of something new, an Earth that had begun to respond. Of course, that interpretation was speculative, even poetic. No scientist would claim that the planet was speaking. Yet for those who spent their lives watching its signals, it was hard to shake the feeling that the Earth was not silent. It was simply using a language we had only just begun to understand. And in that quiet hum of data, filtered through decades of light, shadow, and orbit, one truth became clear. We were no longer just observers of the Earth. We had become participants in its transformation and witnesses to its reply. Part 9 echoes across the world. The human response, the truth was undeniable now. By the early 2030s, the data had spoken louder than politics, louder than denial, louder than hope. What had once been theory was now evidence written in light and temperature, the fingerprints of a species transforming its own world. And as the world looked back at itself through the lens of satellites, humanity began to split in its response. Some saw salvation in the data, others saw accusation. In Geneva, the United Nations convened an emergency assembly to address what the press was calling the Great Imbalance, the widening gap between Earth's absorbed and emitted energy, first identified by Landsat's global energy readings and confirmed by the Sentinel and Aqua missions. For the first time, climate models and satellite observations were in perfect agreement. The planet was warming faster than ever measured before. But what truly stunned policymakers wasn't the temperature, it was the precision of the images. Landsat's half-century record could now trace not just trends, but responsibility. The data revealed with forensic clarity how emissions and land use from specific regions correlated with measurable surface changes. Deforestation scars visible from space, megacities glowing hotter each year, methane plumes rising from industrial zones. The planet's reflection had become a map of accountability. In classrooms from Nairobi to New York, teachers began showing Landsat time-lapse as living history lessons. Students could scroll backward through time, watching glaciers vanish, forests fade, and cities bloom like spreading fires. It changed how an entire generation understood time itself. Environmental change was no longer abstract. It was visual, tangible, immediate. In rural Indonesia, farmers used open Landsat data to predict flooding seasons and protect their crops. In Chile, water managers monitored reservoirs pixel by pixel to plan for drought. In Kenya, scientists used Landsat imagery to detect illegal mining and restore degraded land. Everywhere, satellites had become instruments of survival. But in the corridors of power, the same images became instruments of confrontation. Some governments accused others of manipulating satellite data for political ends. A few nations even attempted to restrict access to certain regions, citing sovereign image rights. Yet the data was already decentralized, stored in global cloud archives, mirrored by academic institutions and NGOs across continents. No one owned the view from space anymore, and that, in itself, was revolutionary. In the years following the release of the Global Spectral Atlas, a massive public database combining Landsat, Sentinel, and MODI's archives, scientists began referring to humanity's new perspective as the anthropogenic mirror. For the first time, the entire planet could be observed as a single system, with humans woven through it like veins through flesh. The boundary between the natural and the artificial had blurred into irrelevance. Cities glowed like reefs of light in the darkness. Roads formed branching networks indistinguishable from river deltas. It wasn't just a planet under observation anymore. It was a portrait of civilization itself. But the response wasn't purely scientific. It was emotional. In Tokyo, an art exhibit projected a 50-year Landsat time-lapse of Earth onto the ceiling of a cathedral-like dome. Visitors stood beneath it in silence as the planet's surface pulsed and shifted, glaciers retreating, forests spreading and shrinking, deserts expanding like spilled ink. Many left in tears. In Paris, an orchestra performed a piece titled Spectral Earth, composed entirely from sonified satellite data. Each pixel translated into sound frequencies. The result was haunting. A deep, resonant hum that rose and fell like the breath of something immense and alive. Even religion found new language in the data. Some spiritual leaders called the view from orbit a form of revelation, the eye of the divine turned inward. Others declared it a mirror of human sin. The Vatican's Pontifical Academy issued a statement describing the Landsat archive as a record of stewardship and betrayal, written by light. But amid all the awe, one question began to echo in every conference, newsroom, and lab. What if the Earth is warning us? Not through storms or quakes, but through patterns we've learned to read too late. In 2032, a group of data scientists in Norway published an analysis that stunned the world. Using AI trained on 5 decades of Landsat and climate data, they found evidence of synchronized phase shifts across multiple biomes, deserts, rainforests, and oceans, all accelerating in rhythm. It wasn't random. The planet's systems were moving in concert like instruments tuning to the same key. The implication was terrifying. Global feedback loops may not unfold gradually, but all at once. And still, Landsat continued to orbit, unblinking. It recorded the aftermath of wildfires in California and Greece, the drowning of coastal towns in Bangladesh, the rapid expansion of solar farms across the Sahara. It captured humanity's despair and its defiance, because even as disasters mounted, something else was rising: adaptation. New cities were being built from reflective materials that cooled themselves. Nations agreed to reforest entire regions using drone-assisted planting. Scientists in Iceland drilled into the basalt crust to trap carbon permanently in stone. Each innovation was tracked, verified, and celebrated through the same satellites that had once shown the damage. In a strange way, the machines that revealed the problem had also become our partners in repair. Through Landsat's gaze, the Earth no longer appeared as a victim or a warning, but as a living story still being written. And the next chapter, for better or worse, would depend on whether humanity could finally learn from the image it could no longer look away from. Part 10, The Legacy of Light. 50 years of watching ourselves, there are few human endeavors that persist long enough to become part of history itself. The Landsat program is one of them. Half a century has passed since that first fragile satellite lifted from the California coast, carrying with it the hopes of a handful of scientists who simply wanted to see the Earth more clearly. What they began in the 1970s has now become one of the most complete visual records of any planet in the known universe. An unbroken chronicle of light, color, and change. 50 years of watching ourselves. In a climate-controlled archive in Sioux Falls, South Dakota, lies one of the most extraordinary libraries in existence. It doesn't contain books, but pixels. Millions upon millions of them. Each represents 30 meters of the planet's surface, captured every 16 days for 5 decades. It is the memory of Earth. Every glacier, every coastline, every floodplain and forest, photographed over and over again. You can scroll backward through time and watch the world breathe. Ice receding, forests vanishing, cities glowing brighter, deserts creeping forward. You can measure the planet's heartbeat in spectral light. This is not just data. It's history written in photons. When the first Landsat images were beamed back in 1972, they arrived as grainy black and white film strips that scientists hung on light tables, squinting to trace rivers and ridges. Today, the same images live in the cloud, processed in seconds, accessible to anyone with an internet connection. The journey from film to algorithm mirrors humanity's own transformation, from isolated observers to a connected species staring at a single shared home. Yet what makes the Landsat record truly unique is its continuity. Every satellite, from ERTS-1 to Landsat-9, was calibrated against its predecessors. Each image aligns perfectly with those before it, creating a dataset of staggering precision. This consistency allows scientists to compare today's forests, lakes, and coastlines with those from the 1970s, as if time itself were just another coordinate. It's this continuity that gives Landsat its power and its poetry. You can zoom into the Mississippi Delta and see it evolve like a living creature, its sediment veins shifting and reforming year by year. You can trace the rise of Dubai from a few desert roads to a metropolis of mirrored towers. You can watch the Aral Sea disappear, pixel by pixel, and then see small lakes begin to reappear where humans dared to restore them. Each image a sentence, each orbit a chapter. Together, a book written by sunlight. Over the decades, the Landsat archive has become indispensable, the foundation for almost every environmental model in existence. Climate scientists use it to validate temperature and moisture trends. Ecologists use it to track species habitats. Economists use it to map agricultural yields, migration patterns, and the growth of cities. Even disaster response depends on it. When hurricanes tear through coastlines or wildfires consume mountain forests, emergency teams turn to Landsat data to assess the damage. In that sense, every life saved after a disaster owes something, however small, to a machine 700 kilometers above the Earth, quietly watching, recording, and remembering. But beyond the science, there's a deeper, almost spiritual aspect to what Landsat represents. For the first time in history, an entire species has kept a visual record of its planet's transformation, not from myth or memory, but from measurement. The images tell a story that no historian, poet, or prophet could have captured. The exact moment when humanity became a geological force. We've written ourselves into the layers of the Earth, and Landsat is the witness. Its data has shown our impact with ruthless clarity. The forests we've erased, the seas we've poisoned, the ice we've melted. But it's also shown our resilience. The forests regrown, the wetlands restored, the cities redesigned to coexist rather than consume. Through its eyes, we can see both our mistakes and our capacity for change. In 2021, on the 50th anniversary of the Landsat program, NASA released a special visualization, a time-lapse of the entire planet stitched together from decades of images. They called it the Living Atlas. It begins in black and white, the first raw photos from the 1970s, then bursts into color as new satellites join the network. Forests shimmer in red, deserts in gold, oceans in deep blue. As the years tick by, the animation becomes almost hypnotic. Continents glowing, clouds swirling, cities pulsing like circuits. But what makes it breathtaking isn't the technology. It's the story hidden inside the motion. The story of a planet that keeps changing, and of a species learning, slowly, painfully, to understand what it's doing. When people see those images, something happens. Politicians fall silent. Children stare. Scientists, hardened by decades of data, still feel awe. Because what Landsat has captured isn't just the state of the Earth. It's the proof of perspective. For the first time, we can truly see ourselves from the outside. And perhaps that's the legacy of light, not merely to observe, but to awaken. Because one day, the last Landsat satellite will fall silent. Its orbit will decay, its instruments will cool, and its final transmission will fade into static. But its legacy will remain, encoded in petabytes of color, stored in the collective consciousness of a species that once looked up and decided to look back down. And maybe, just maybe, that decision will prove to be the most important we ever made. Part 11, Beyond Earth. Lessons from the Blue Planet. In the beginning, we looked to the stars to understand our place in the cosmos. But after 50 years of watching Earth, a quiet truth emerged. To truly comprehend the universe, we first had to understand the planet we came from. The story of Landsat, and of the thousands of satellites that followed, is not just a story of observation. It's a story of reflection. In studying Earth from orbit, humanity discovered something profound, that the act of looking outward inevitably brings us inward. In 1972, when Landsat 1 began transmitting its first images, NASA's ambitions were focused on Mars, the Moon, and beyond. Few could have imagined that the most transformative discoveries would come from turning the camera homeward. Yet, in the decades that followed, the images of our own world proved as revolutionary as any photograph from deep space. They revealed a truth both simple and staggering, that life, in all its complexity, thrives only within a narrow band of conditions. A fragile balance of sunlight, temperature, and chemistry. Everything that sustains us, the forests, the oceans, the atmosphere, exists in a thin film no thicker than a coat of paint on a classroom globe. Seen from orbit, the Earth is a paradox. Vast and delicate, ancient and immediate, infinite in appearance yet limited in substance. That realization changed science, changed politics, changed us. The lessons learned from Landsat's gaze have reached far beyond our atmosphere. When engineers designed Mars orbiters and lunar reconnaissance missions, they borrowed directly from Landsat's spectral systems. The same methods used to detect vegetation on Earth were repurposed to identify minerals, ice, and chemical traces on other worlds. In 2003, when NASA's Spirit and Opportunity rovers searched the Martian surface for signs of water, their navigation systems used Earth-based imaging as a calibration model, Landsat data helping us recognize familiar geological shapes on an alien planet. The same algorithms that track crop health in Kansas are now used to analyze the ice caps of Mars. The same infrared imaging that maps fires in Australia measures volcanic activity on Venus and Io. Landsat's legacy became a universal toolkit, a way of seeing not just Earth, but any world that bears the marks of change. Yet the most powerful lesson Landsat taught us wasn't technological. It was philosophical. Through its patient, repetitive watching, humanity learned that observation is an act of care. To look closely is to acknowledge connection, to admit that what happens in one part of the system affects the whole. When astronauts aboard the International Space Station looked down, they described something called the overview effect, a shift in consciousness brought on by seeing the planet without borders. Landsat has given that same effect to all of humanity, without leaving the ground. Billions of people, through a screen, have now seen their home as a single, breathing organism. The boundaries that divide nations disappear. What remains is weather, ocean, light. The scientific data transformed into something else entirely: empathy. But empathy alone does not guarantee change. As humanity continues to explore beyond Earth, it carries with it both its ingenuity and its contradictions. Plans for colonies on the Moon and Mars grow ever more ambitious, cities under domes, greenhouses fed by recycled air and sunlight. The irony is not lost on the scientists who spent their lives studying this planet. To build a livable world elsewhere, we must first recreate the systems we have endangered here. In that sense, Earth has become the prototype, a fragile model for survival. From space, Mars looks quiet and beautiful, but it's a dead world. Venus glows like a jewel, but it's a furnace. Among the hundreds of exoplanets discovered, not one yet shows the spectral fingerprint of a living biosphere. And so, Landsat's message echoes louder than ever. There is no planet B, not yet, perhaps not ever. The blue marble that hangs in the void remains unique, and the record of its life, written in decades of satellite imagery, may be the rarest story in the cosmos. A planet that became aware of itself. In recent years, as artificial intelligence has begun decoding the vast Landsat archives, patterns once invisible to human eyes have emerged: fractal relationships between rivers and coastlines, atmospheric rhythms repeating like music, the geometry of ecosystems mirroring the logic of galaxies. The same physical laws that govern starlight seem to shape rainfall. The same mathematics of motion that describes spiral galaxies appear in the whirls of hurricanes. The line between Earth science and cosmology blurs. To study Earth deeply enough, it seems, is to glimpse the universal, the blueprint of balance, the architecture of life. And perhaps that is the final lesson from 50 years of watching the blue planet. That knowledge, divorced from wonder, is incomplete. That data without humility is dangerous. That vision, the simple act of seeing, can be the most transformative force of all. Because through Landsat's lens, we've come to understand that the Earth is not something we stand upon. It's something we're part of. The story is ours. Its fate is ours. And if we can learn to see it, truly see it, then perhaps we can learn to protect it, not as stewards of a distant object, but as participants in a living miracle. Part 12. The Edge of Tomorrow. A new eye in the sky. The morning was clear when Landsat 9 lifted from the pad at Vandenberg Space Force Base. Another column of flame. Another leap into silence. Another promise to continue what had begun half a century earlier. It was September 27, 2021. Nearly 50 years to the day since Landsat 1 first opened its eyes. But this was not just a replacement. Landsat 9 represented continuity in the truest sense. The next link in a chain of observation that had never been broken, even as the planet beneath it changed beyond recognition. As the rocket arced eastward over the Pacific, carrying its delicate instruments through the thinning atmosphere, scientists around the world watched the live stream in reverent quiet. They knew that what was being preserved that day wasn't merely a mission. It was memory. Within hours of deployment, the satellite aligned with Landsat 8 in orbit, each tracing the same global path 16 days apart. Together, they began an elegant dance, alternating passes to double the frequency of observation. The result: a full image of the entire Earth every 8 days. It was the most detailed, continuous portrait of our planet ever achieved. And the timing could not have been more critical. By the early 2020s, the world had entered what scientists called the decisive decade. Carbon emissions were at their highest in history. Forests were burning faster than they could regrow. Floods, droughts, and heat waves were no longer isolated disasters. They were global, overlapping, and intensifying. Humanity needed vision, and Landsat 9 provided it. Equipped with advanced sensors, it could see more clearly than any of its predecessors. Its operational land imager 2 captured light in 11 spectral bands, revealing details invisible to the human eye. Its thermal infrared sensor could measure temperature changes across continents, detecting shifts as small as a single degree. From orbit, it saw the faintest signatures of drought creeping across the Horn of Africa. It traced algal blooms expanding in the warming waters of the Baltic Sea. It watched Greenland's glaciers fracture and flow toward the ocean, frame by frame. Each image was a warning, but also a tool, proof that knowledge could guide adaptation. For the scientists managing the mission, there was something almost sacred about it. Landsat had become more than a satellite. It was a covenant between generations. Each one built upon the legacy of the last, ensuring that the record of Earth, our only home, would never be lost. And so, Landsat 9 was not an ending, but a renewal. At NASA's Goddard Space Flight Center, Mission Director Jeff Masick described it perfectly. "We've built a family of satellites that has outlived its creators. They're our eyes in the sky, and they'll still be watching long after we're gone." His words echoed through laboratories and classrooms around the world. Meanwhile, new partnerships were forming. NASA and the USGS announced plans for Landsat Next, a trio of satellites designed to launch in the mid-2030s. Together, they would capture global imagery every 2 to 3 days, a constant, living video feed of the planet. Unlike its predecessors, Landsat Next would be built for the age of artificial intelligence. Each satellite would process data autonomously, identifying environmental anomalies in real time. Sudden deforestation, illegal mining, unseasonal fires, rapid glacier melt. Warnings would be sent directly to scientists and governments within minutes. The planet itself would become a self-reporting system. But as technology advanced, so did the ethical questions. If the Earth was now watched every day, from every angle, who decided what to see? What to record? What to ignore? Could the very tools that helped protect the planet also become instruments of control? For now, the answers remain uncertain. But the ideal that drives Landsat endures. Open data, open science, and shared stewardship of a shared world. When the first color image from Landsat 9 was released, a swath of the Russian Arctic glowing in shades of teal and amber, it was breathtaking. The detail was exquisite, the clarity surreal. Yet beneath the beauty lay the quiet melancholy of understanding. Every pixel in that image represented change. To look at it was to feel both awe and responsibility. As night falls, Landsat 8 and Landsat 9 continue their endless orbit, side by side, tracing the same path through the dark. Below them, city lights glitter across the continents like constellations, proof of the species that sent them there. From their vantage point, the difference between human creation and natural wonder disappears. The glowing veins of highways and rivers, the clusters of light and forest, the delicate curve of cloud and coast, it all merges into a single image of complexity and grace. This ultimately is what Landsat has given us, the ability to see the unity within chaos, the pattern within time, the miracle within the ordinary. 50 years ago, we launched a camera into space to learn about Earth. Today, that camera and all that followed has taught us something greater, that to observe is to remember. That to remember is to understand. And that understanding, if we let it, might be the first step toward survival. Part 13, The Light That Remains. Closing reflections. It always ends the same way, with silence. No engines, no thunder, no applause. Just the quiet hum of orbit. Up there, above the atmosphere, the Landsat satellites circle a world of oceans and clouds, continents and scars. They do not sleep, they do not rest. Every 99 minutes, another image, another heartbeat of the planet preserved. For half a century, they have kept this vigil. And though technology will evolve, though new satellites will replace the old, the mission remains unchanged, to see and to remember. When future generations look back on this era, they may not recall the names of the satellites or the engineers who built them, but they will inherit what those machines saw, a record of the Earth at a crossroads. Because in every image ever taken by Landsat, there is a question buried in the pixels. What will we do with what we know? The story began with curiosity, a desire to understand the land beneath our feet. But it grew into something far greater, a revelation about ourselves. We learned that our planet is not infinite. We learned that every action leaves a trace. We learned that light can be a witness. The archive that began in 1972 has become the collective memory of a species that finally learned to look. And what a memory it is. It holds the ghost rivers of the Aral Sea, the emerald rebirth of Costa Rican forests, the silver scars of mining fields in Peru, the slow bloom of megacities across Africa and Asia, the retreat of glaciers that once carved continents, the growing deserts that now whisper where forests stood, a library of transformation, a record of consequence, a mirror of becoming. Perhaps the greatest irony is that the technology meant to distance us from Earth has brought us closer to it. From orbit, we discovered not isolation but connection. The way rivers, winds, and clouds weave a single pattern of life. We discovered that borders are illusions, that there is no elsewhere, only here. And in that realization lies both humility and hope. Because the same intelligence that warms the planet can also heal it. The same machines that mapped destruction can guide restoration. The same data that revealed the wound can now help us mend it. The future of Earth will not be written in stone or scripture. It will be written in light. In the great darkness of space, Earth glows faintly blue, small, fragile, and alive. Every photon reflected from its surface carries a story of water and wind, of forests and fire, of the brief species that learned to see. That light travels outward, endlessly. Somewhere, light from this very moment, from your city, your ocean, your sky, is already moving beyond the edge of our solar system, carrying with it the spectral signature of a living world. Perhaps one day, another intelligence will intercept that light and study it as we study the stars. And perhaps they will see what we have seen, a world of immense beauty and consequence, a species capable of wonder and error, planet worth remembering. When the final Landsat satellite completes its last orbit, when its batteries fade and its signal drifts into static, the story will not truly end, because the light it captured will endure, stored, studied, shared, and remembered. Proof that we once looked at our world not with conquest in our hearts, but with curiosity and love. So now the gaze continues. Above the clouds, the twin eyes of Landsat 8 and 9 glide silently through their endless dawn. Below them, the Earth turns, oceans flashing, continents gleaming, humanity still in motion. Every orbit, another frame in the story of everything. And in the spaces between those frames, in the silence, in the light, in the watching, we find the only answer that ever mattered. To see the world is to know it. To know it is to protect it. And to protect it is to finally understand who we are. Part 14, Epilogue. The long look home, the orbit endures. Above a turning Earth, where night and day chase each other across oceans and mountains, A small machine of mirrors and memory glides through the void. The solar panels unfold like wings of light. Its sensors open, collecting photons older than breath. Another pass begins. Another chapter recorded. Down below, humanity continues. Cities rising, rivers shifting, forests burning and reborn. But somewhere in a laboratory, a scientist sits before a glowing screen, watching the data arrive in pulses of color. And there it is again, the same blue curve, the same fragile shimmer. The living Earth, still speaking through the silence. In the grand history of exploration, the Landsat program might seem humble. It never left Earth's orbit, never touched another world. Yet, in a way, it accomplished something greater. It taught us to explore home. Through half a century of watching, we learned that discovery doesn't always mean reaching outward. Sometimes it means turning inward to see the miracle that was there all along. And in doing so, we achieved what might be the most human act imaginable. We learned to remember. The next generation of satellites, Landsat Next, Sentinel-5, PACE, NISAR, are already taking shape, each carrying the lineage of those that came before. They will be smarter, faster, and infinitely more detailed. They will measure the pulse of Earth not every 16 days, but every day, a near-living film of our planet in motion. Someday soon, the boundary between seeing and knowing will blur completely. Artificial intelligence will translate data into instant insight. The Earth will monitor itself through a network of machines born from human imagination. But no matter how advanced our tools become, they will all trace their lineage back to a single moment. A rocket on a clear morning in 1972. A satellite no larger than a car. And a question whispered into the void. What does our home look like from above? Because every image ever captured by Landsat, from the green veins of the Amazon to the icy mirrors of Antarctica, contains the imprint of the same story. The story of a species learning to see itself not as separate, but as part of a greater whole. In time, the archives of Landsat will outlive their creators. The satellites will fall silent, but the images will remain. A time capsule of an age when we finally began to understand what it means to belong to a world. Perhaps centuries from now, when the last remnants of our civilization are gone, and new eyes, human or otherwise, look back upon the record, they will see what we saw.